topic is on total count of RBC. Total count of WBC is already done. It's the calculation part is a bit more complicated than that of WBC. Actually, nothing is complicated if you understand. So, WBC squares are 4 squares. We count the WBCs in 4 squares, 1 square meter each, and the gap between the covered slip and the Neubauer chamber where we are charging the blood is 1/10 millimeter. Sorry, 1 square millimeter, not meter. I think I mentioned meter by mistake. 1 square millimeter, 1/10 millimeter is the what we consider the height. So, in the books it is written volume of the squares, but very strictly speaking it is not the volume of the squares. Squares are on a you may imagine it to be a 2-dimensional. In that way you think it to be a 2-dimensional surface, like there can be an area of this room but not of the floor or of the roof. Okay, just there can be an area of this room but not of the floor or the roof. So, it has to be a 3-dimensional space for us to talk about a volume. So, strictly speaking we should say volume of blood overlying the squares after uniform distribution. We charge the blood, we are expecting if it is the charging is okay, then this is uniform distribution. So, the volume of the blood overlying the squares we are calculating, that is in case of WBCs it will be 1 into 1 into 1/10 for each WBC square. For 4 WBC square it is 4 times that. So, it is 4/10 or 2/5 cubic millimeter. You have done this in WBC. Those who have not done the calculation part, so this is the calculation part for the WBC one. 2/5 millimeter cube contains so many cells, whatever you have counted. If it is a capital X or capital N, then it is for 1 cubic millimeter it is that 5x by 2 or that's 5n by 2. So, but that is diluted blood. So, for undiluted blood it will be into 20 for WBC because the dilution factor is 20. Again think of the pipette, think of the RBC and WBC pipette. In case of WBC pipette, dilution is 20 times because first blood is taken up to 0.5 and this is pushed up in the bulb, and then after mixing the part in the stem, that means the lower portion of the stem below the bulb, that is discarded. So, it is 11 minus 1, 11 is the figure written above the stem. So, that is 11 parts of volume and this is 0.5 part of volume is blood, but 1 is discarded which is below the stem, that is only fluid, contains no blood because mixing occurs in the blood. The fluid, when it is pipetted, it is pushed up along with the blood in the bulb. So, below the bulb is only the fluid. Do you get it? Don't look blank, make it interactive. You understand? You? Yes, you understood? You have done this WBC? No, you are also in there. So, there must be a reason. So, if the HOD wants, you have to show the reason, official reason why you are not there. So, that is, if you do 11 minus 1, we will revise it maybe till the next week, but not after that, RBC and WBC. We won't get time. So, today you do RBC, we will see whether WBC can be done again, but don't think that only one class will suffice for practice. That is why we are revising. So, if you think I was not present on that day, okay, I will do one day and it will all be okay, that is also a wrong concept to have. Anyway, as you have not done, you have to do. So, 11 minus 1 by 0.5 is the dilution. Similarly, the dilution in case of RBC is 101 minus 1 by 0.5. Okay, and you will see structurally the bulb of the RBC pipette is larger because this the bulb 0.5 is the same, but it will correspond not to a unit of volume, the standard units of volume, it is just parts of volume. I do not know in microliter or something or cubic millimeter, whatever volume, unit of volume we take, how much that 0.5 measures. You just compare with the hemoglobin pipette, that 0.5 may be around 10-15 microliter. If the bore of the hemoglobin pipette is of the same width, if we consider it to be the same width, then that 0.5 is around say 15 microliter maybe. I do not know, I mean, nobody knows because that is RBC and WBC pipettes are, we have never thought of while manufacturing that what microliter it is, that is the 0.5 part of volume. It was seen, it is seen during manufacturing that one, whatever is labeled 1 is double of 0.5, whatever is labeled 11 is that times of 0.5. That means say that is 22 times of 0.5. or 101 is so much times of 0.5, 202 times of 0.5, but not the exact not what it is exactly in terms of some units of volume. In hemoglobin it's 20 microliter, or if there are some pipettes 10 microliter, then you have to take blood twice, otherwise you have to multiply 2 at last. It is better to take blood twice because it is better to work with 20 microliter. That is the standard for that making acid hematine. So don't do it simply like that. I take 10, I do the experiment and then multiply it by 2, because better is the experiment standard is so that the standard, it has been standardized such that, it has been standardized such that the acid hematine is formed with 20 microliter. So we have to pipette it 2 times if the pipette is 10 microliter. Usually we try to arrange the 20 microliter pipettes during the examination, but if it is 10 microliter, then you have to do it twice. So in case of RBCs, the central square, and in the central square, the whole square, it is the central square of the whole improved Neubauer chamber 3 mm into 3 mm. So again it's 1 mm into 1 mm, and this is divided into, just to revise the calculation once, 1, 2, 3, 4, 25 equal squares. So this 25 equal squares counting is done in the corner 4 and the central one. How to identify the corner 4? So on this side of the left upper, there will be triple lines left and upper, and on the other 2 sides there will be similar RBC squares. In case of WBC squares, left upper say WBC squares, left and upper there is nothing, not the chamber itself, and on the other sides there are triple lines. In this case, left and upper are triple lines and the right and lower are the similar RBC squares, identical RBC squares. So conventionally we start with the left upper, you can start with any of these, but if you start with the left upper, you move 3 and reach this and confirm this by the presence of triple lines on the particular sides. If it is in case of right upper, right and upper side particular, it will be triple lines, other sides RBC square. Move down 3 squares, 3 means 4, leaving 3, the fourth one, again leaving 3, the fourth one to the left after counting, and the central one is found by going 2 up and 2 towards the middle. If you start from any other square, you have to modify it accordingly. If you start with this and end with this, you have to go 2 down and 2 left, but I think for the beginners it is better to do what is taught conventionally. So start with the left upper one. So instead of the central square, if you take any of the other squares, that is actually sufficient for your result. Why we do not count 25? It will take a long time, it is not possible counting 5. Why are taking the central square? Why instead of the central square after completing the 4 we are not going to this, or why you are actually counting all the corner squares and the central squares? Because theoretically we are saying blood is distributed uniformly. So my counting, the counting is so that I have taken that distribution is uniform. If distribution is non-uniform, already my result is going towards some error, bit of error. So considering distribution is uniform, whatever density of cells will be there in the central squares will be in the corner squares. So the reason is that, and these things, all these things are not so well explained in books, so not explained in books. Why? So this is the reason, because the distribution is uniform, so the central squares and the central of the RBC squares and the 4 corner squares, that's it is taken. Now how are these, each of these squares, this is, if this is the large RBC squares and each one of these 25 is medium, then each of these medium square is divided into 4 into 4, and that 4 into 4. So 4 into 4, and that is by those triple lines which are between the RBC and the WBC squares in the other squares. Those triple lines contribute to this division. So that is 4 into 4. So we are calculating it. Actually RBC cells are more dense, much more in number than at WBCs. So we are calculating it in this square. Say this square I am counting. So we take the rule of L, that we avoid counting when we are taking this particular small RBC square. We are counting on the left and the lower side, but avoiding the right and the upper side. Reason for that is, If we try to count all the margins, then for the next cell it is so small that some cells may be counted twice. To avoid that, upper and right margins are left out. You get this thing? So that some cells may be lying on the margins also. So those cells are not counted twice. After all the cells following the rule of L, this is done. This square plus this margin and this margin. After all this is completed, what happens? This is complete and all the central part is complete. This is the whole, say the right lower or the left upper. So this is complete. Now count on these margins. So this is complete counting of one such cell of the 5 cells of one such square, one such medium square. Cells means, sorry, not cells, one such medium square. Cells here we are referring to the blood cells. So don't call the squares as cells or you will confuse. So cells are the blood cells, squares are the squares. So medium square is complete when we follow the rule of L and count the small squares following the rule of L. Inside, do you get it? Don't look blank, you at the back. Do you get the thing? Have you read it in the book? So you get it now, but read the books, otherwise this is not so easy. You are reading 3 subjects together, studying. If at all you are studying 3 subjects together. So I am teaching this same topic for 10 years now. But you are a beginner, so you have to put in some effort. Read the textbooks. Come prepare for the class. So this is counted like this. So after this is complete, you write the value. Say like this, small x1 for the left upper square, x2 for the left lower square, x3, x4, x5, and capital X is x1 plus x2 plus x3 plus x4 plus x5. Finally, 1 milli. So now what is the calculation? 1 medium RBC square is, in case of WBC squares, large and small, no further divisions. In case of RBC square, large, medium, small. So 1 medium square is 1 by 5 into 1 by 5. So the calculation is area is 1 by 5 into 1 by 5. So again, volume of squares, it is written in the book volume of squares, but strictly it is volume of blood overlying the squares. Volume of blood overlying one medium square RBC square is 1 by 5 into 1 by 5 into 1 by 10. For 5 such, it is 5 times of it. So it's 1 by 50 millimeter cube. So we are counting cells in 1 by 50 millimeter cube of diluted or undiluted blood? Diluted blood. So 1 by 50 millimeter cube of diluted blood contains that capital X. So 1 millimeter cube contains 50x. Dilution is 200 times, so it is 10,000 x. 15 to 200 is 10,000. 10,000 x, put the value of x at the last, which is x1 plus x2 plus x3 plus x4 plus x5. And when you write in the exam, you have to explain each x1. Again, as we are mentioning in the theoretical classes, when you write in the exam, you have to or in the practical notebooks or in the exam, what is x1 or what is, say, capital N, N1, N2. So what is N2? It is not a universally accepted term or abbreviation, whatever. It is not a universally accepted, that is note that N1 is the number of cells in the left upper medium RBC square. So once you have to write it, N2, that is the number of number of RBCs counted in the right upper, conventionally left upper, then right upper, right lower, left lower, last central. X5 is in the central. So total of this is capital X. So this has to be done, and don't get it, we can do it likewise also more but it will, I think, become more complicated. What are the number of squares in each of the medium squares? So it will come the same, 4 into 4, 16. So what is the volume of each small square? If someone asks, you have to tell, it is 1 by, not volume of squares, volume of blood overlying the squares, or area of each small square 1 by 20 into 1 by 20, okay, and volume of the blood overlying it is 1 by 20 into 1 by 20 into 1 by 10. Now how many such squares are counted? How many such squares are counted if I go for the count of RBCs? So it can, whatever I write as 5 into 1 by 5 in 1 by 5 into 1 by 5 into 1 by 10. If I take the small squares, it is 1 by 20 into 1 by 20 into 1 by 10, but number of such squares counted are actually 80, because in each 5 they are divided into 16. So number is 80, so it will come the same. Okay, it's the same. So 80 into the smallest squares. The calculation can be done like that also. We are counting, actually we are counting each small square. So to get one medium square, we are counting 16 small squares. We are actually, by the rule of L, we are counting the small squares, the cells in the small squares. So there are 80 such cells, but the area of his square is 1 by 20 into 1 by 20 square millimeter. So volume of blood overlying it is 1 by 20 into 1 by 20 into 1 by 10. Everybody get it? Same thing. So better to write it as 80 into 1 by 20, but that may confuse you in the beginning. So write it as 5 into 1 by 5 into 1 by 5 into 1 by 10. Actually I am counting 80 cells, 80 small cells, not 5 media. I am not counting one medium cell altogether. So it should be like that, 80 into, it is better to write like that, 80 into 1 by 20 into 1 by 20 into 1 by 10, but 5 into 1 by 5, that will suffice. So this is the counting part, but charging part, what you have to do hands on. Okay.